Hello everyone. Now here is an even faster approach to check whether the number is a prime number or not. This uses something called as a primality test. The primality test is called as 6k plus minus 1 primality test. Basically it says that just like in the previous video what we had done, we had eliminated all the multiples of 2, all the even numbers, and we were only checking by odd numbers. Now this primality test says that going one step further, you only need to check whether the numbers which are of the form 6k plus 1 or 6k minus 1, only those numbers have to be checked for being divisors. So for example, if you say k equal to 0, then 6 into 0 plus 1 is 1, 6 into 0 minus 1 is minus 1, so that is invalid. Then k equal to 1, 6 minus 1 is 5 and 6 plus 1 is 7, so you'll check for 5 and 7. And from 5 and 7, starting from 5 and 7, now you will go plus 6 every time. So when k equal to 2, it will be 6 into 2 minus 1, that is 11, and 6 into 2 plus 1, that is 13. Okay, so now what we do over here is, okay, let's focus on this loop first. So we start with I equal to 5 and we go in increments of 6. And inside this we check whether the number is divisible by I or it is divisible by I plus 2. Okay, so this is 6k minus 1 and this is 6k plus 1. Okay, and another thing that we have to do here is, now because the primality test only holds true for numbers which are greater than 3. So if it is less than equal to 1, false, and if it is not less than equal to 1 but it is less than equal to 3, that means it's either 2 or 3, so it will return true. Now we also have these additional checks whether n mod 2 equal to 0 or n mod 3 equal to 0. Okay, so this is just a constant time one check that we do. If this is if this is true, then the number cannot be a prime number, because for example this primality test will not work for multiples of 3. For example, if we want to check whether 9 is a prime number or not, so it will check divisibility by 5, it will check divisibility by 7, and then it will simply say that because neither of them divides 9, 9 is prime, which will be wrong, right? So basically divisibility by 2 and divisibility by 3, if we check once, then all the cases are handled. So now how fast is this? So again, for 1093 example, already we have the square root optimization, so it will only run for 32 times. It will check for 32 numbers only up to the square root of 1093. And even amongst that, in the previous video we were checking for odd numbers, so it was almost like running for 16 times. Now in this case it will simply run for, if you're checking for 1093, it will run for 5, it will check for 5, 7, 11, 13, 17, 19, 23 and 25, 29, 31. So only, let's say only for 10 times, the loop will run only for 10 times. And this reduction is significant for larger prime numbers, when you have prime numbers with hundreds of digits. So in that case this is optimal. Okay, but just for your information, for your knowledge, I wanted to share this approach with you all. Okay, other part of the code remains the same, how you print it as a Floyd's triangle. Okay, so thanks for watching.